Okay, this video is about natural logarithms. All right, so some vocabulary. What we call the common logarithm is what we talked about yesterday, and it looks like this: log base 10 of x. So anything with the base 10 is a logarithm, your common logarithm. So yesterday we introduced the number e. So now we can move in and say, okay, what's the log base e of something? Well, anytime the base is that number e, it becomes what we call a natural log. So, and we abbreviate that LN, natural logarithm. And this was discovered by a dude, and the reason it's LN, not NL, is because it was in French, and it was like la naturelle. That's why it's LN. So this represents a logarithm base e. Base of e, this has a base of 10. So make sure you keep those straight. Common log base 10, natural log base e. So to evaluate these, you're going to use the natural log button on your calculator, and it's right beside the number 4, and you'll see it in class, but it's just to the left of number 4. It's the natural log. So you're just going to type these in just straight up. The natural log of 2, and when you type that in, you're going to get 0.693. Remembering we're rounding to 3 places. In the next part, I'm going to find the natural log, remember the base e, of 0.3. So e to what power gives me 0.3? You're going to get negative 1.204. So my powers can be negative. Notice this. My powers can be negative. Lastly, the natural log base e of negative 1. When you enter that in your calculator, you're going to get an error. Because what that is saying is e to what power gives me a negative 1. Well, even if you raise e to a negative power, that's just going to make it a fraction. It's not going to make it a negative number. So it's impossible to take a natural log of a negative number. So keep that in mind. You cannot take the logarithm of a negative number, and this will show up in a couple days, but keep this in the back of your mind. So don't be surprised if you get error as an answer. All right, properties of natural logarithms. These are very similar to the ones we did with the common log that we just applied to natural log. Number 1, natural log of 1 is 0, because what that's saying is, when the base is e, e to the 0 power equals 1. Anything to the 0 power equals 1. The second one, natural log base e of e is 1, because, that's what the BC is, because e, remember the swirl, the base is an e there, e to the first power is e. Anything to the first power is itself. Thirdly, natural log of e to the x power equals x, because, remember the base, if the bases match, the base of e matches this e, because you're swirling here, e to the x equals e to the x. And then lastly, if the natural log of one number equals the natural log of another, then those two numbers, x and y, are the same. All right, again, just kind of repeats of yesterday, we're just using the natural log. Okay, example 2. So let's look at this. E raised to the natural log of 5 power. Well, think about your bases. This goes back to number 3 here. E to the natural log of e. Remember, the bases are the same here. They will cancel out, and my answer is simply a 5. If the bases are the same, whatever's left is your answer. So let's look at this. The natural log of 1 divided by 3. Well, remember this is e down here. E to what power gives me a 1? Anything to the 0 power is always a 1. So that means this is really 0 over 3, which is 0. And lastly, 2 times the natural log of e. Well, natural log, the base is an e. So this is saying e to what power is e? Well, that's just to the first power, so that's a 1. So this is really 2 times 1, so my answer is a 2. Okay, so we use natural logs in some applications, and you're going to have some application problems on your homework. Yes, you will have to read sentences. You can do this. All right, look at example 5. The human memory model was a project that was created to measure, using a test score, how much memory is lost over time. So they would take a test, pass some time, take the same test, and see how the score declined and at what rate, basically. The equation they came up with was this: 75 minus 6 natural logs of t plus 1, where t is the number of months away. So it was between 0 and 12 months, because there's 12 months in a year. So it says, first of all, find the average test score when t is 0. So it's just to plug it in, guys. F of t equals 75 minus 6 natural logs of 0 plus 1 is 1, right? All right, so let's just solve this. You know the properties. Let's see, this is base e. So this is saying e to what power is 1? Well, using those properties, we remember that e to the 0 power is a 1. So I have a 6 times 0. So that's negative 6 times 0 is 0. So 75 minus 0 is 75. So at the very beginning, the average score of the test was the 75. That's what you should take from that. After 2 months, we're going to do the same thing. We're just going to put a t in, or 2 in for t. 75 minus 6 natural logs of 2 plus 1. So it's really a 3. And you would type this in your calculator, being very careful to put everything behind the minus sign in parentheses. Otherwise, it will not calculate correctly. We're coming up with a test score, so you're going to round to the whole number. You're going to get 68. That's after 2 months. So if I was graphing this, which you may or may not have to do, at time 0, times 12 over here, at 0 it was at 75. We just found that out. At 2 months, it's at 68, so we're down here. Okay, at 6 months, let's do this for 6 months. 75 minus 6 natural logs, 6 plus 1. 75 minus 6 natural logs times of 7. Use that calculator, type that in carefully, and you will get a 63. So at 6 months, halfway down, we've just declined a little bit. So what's happening is you're getting a logarithmic curve looking like this. All right, so it's a real-life application of how we use natural logs in everyday life. All right, for the WISC, you're going to have 2 problems to solve. Example 6, example 7. Use those properties and put your answer in the WISC. Good luck and see you in class.